So let's talk about a specific function with a vertical asymptote called 1 over x. If you had to guess where the function 1 over x had a vertical asymptote, what might you think? Well, a common guess is to try x equals 1. So let's give that a shot and see what happens. We'll notice that when we're searching for asymptotes, we don't actually plug the number in. We want to see what happens as we get closer and closer to that number, as this is an asymptote that is experiencing asymptotic behavior that we're looking for. So if we plug in x equals 1.1, we could write f of 1.1 equals 1 over 1.1. And if we were to evaluate this as a decimal, we would get 0.9090 dot dot dot, repeating infinitely until the end of time. If we get it a little closer to 1, let's try 1.01. 1 over 1.01 equals 0.9900. 9900. And so on. Let's do a couple more. Plugging in 1.001. That's 0.999000,999, etc. And lastly, let's get super close. 1 divided by 1.00001. If we type that in a calculator, we get 0.999990, and there's a pattern there as well. What do we notice about this? Well, these numbers get closer and closer and closer to 1. So I don't think there's going to be a vertical asymptote at x equals 1. On the other hand, let's look at what happens when we get closer and closer and closer to x equals 0. Well, if we plug in 0.1, that's going to be 1 over 0.1. That's just 10. 1 over 0.01, that's 100. Plugging in 0.001, that's 1,000. And 1 over 0.00001, getting really close to 0, that's 100,000. Do these appear to be approaching any specific number? I don't think so. This is approaching infinity. And so this appears to be a vertical asymptote. You're welcome to try this on your own from the other side, seeing what happens as we get closer to 0 from the left as well. In class, we are going to get in groups to discuss when do vertical asymptotes occur. We're also going to figure out how to find vertical asymptotes algebraically. And finally, we will look at the concept called holes in a rational function. See you there.